Wow, those were amazing talks. Thanks for joining this live Q&A session. Hey, Luke, Adam, Thomas, Jordi, thanks for joining. So sounds like it's starting to happen now. Live is moving to unreliable delivery end-to-end, and at scale looks like. And it's good to see that reliability and redundancy is being built on top of that at the same time. I guess in Caffeine's case, it was reliability and redundancy always been reliable on unreliable delivery in real time. So let's jump into questions. Luke, over to you first. Some good questions or chat. Quick doesn't work well on high bandwidth delay links, such as satellite links. How does the community plan to tackle that? Is that relevant, or is that something you're trying to optimize for?
Yeah, so it's not too relevant for me, but it is certainly something that I know a lot of other users of Quick have issues with. So I'd like to see something like FEC and Quick or some ways. That being said, you could totally preemptively retransmit in Quick. There are ways around it for sure.
Great. And then where is Warp at? How far is it? And are there any software and hardware OEM support that Warp is also looking for?
Yeah, so we are running Warp in production. I can't really say too much more than that. It's still an experiment. I know that Meta is using Rush in production as well for ingest. So there's certainly some production use cases out there. Warp is, right now I'm really pushing for standardizing it to mostly get those like OEM vendors on board. So there's an IETF meeting in a week and I'm gonna be peddling my draft.
Great. And by the way, thanks John and Brian for the previous questions. This next one is from Neeraj. Congestion is client dependent. So how does client player choose, and or is that, can server side provide that information for congestion and choosing bit rates, et cetera? How does that work between client and server?
Yeah, so it's interesting because traditionally for HLS and Dash, the client picks which rendition to download, but the client really doesn't have that much information. The congestion controller is on the sender side. And what we're doing, and it's probably what I'd recommend for everybody, is have the sender use the low-level congestion control, like basically take straight from BBR what the estimated bit rate is and feed that to the encoder, or feed that, like round down to the nearest rendition. And that works a lot better than trying to do some voodoo magic on the client side to figure out which rendition to download next. Because just in live, you can't really do that. It doesn't work.
Yeah, that's a good point. It's slightly different than how we've thought about ABR and congestion control in the past.
Yeah, we've tried optimizing client side ABR, but you start going into like, I don't know what to do, so let's throw machine learning at it, and it's never good enough.
Yeah. Well, awesome. Maybe move to Adam next. Yeah, this question came up while you were describing that bug, and that's definitely an interesting one, and probably seems like a very common one when you're trying to push large keyframes anytime, whichever protocol this is. But in this case of WebRTC, most likely looks like it was an implementation issue we ran into there. What was this?
Yeah, go ahead.
Yeah, I was curious whether this is mobile browser's implementation of WebRTC. Was this Pion or something else?
So it's the problem is going to arise pretty much anytime you have the combination of those three factors, effectively low motion video, a bit rate that like spikes as a consequence, and very conservative pacing of the packets going out. So you can adjust any one of those three on the sending side, and it pretty much alleviates the problem. So technically, the issue here was on the webrtc.org implementation, but it's not unique to them. It's going to be basically any encoder that does things this way. And it's kind of a difficult problem to mitigate. So you're probably going to see it arising in a lot of different situations. As I mentioned on the final slide of my presentation, we came across this in completely unrelated encoders. The way we discovered it was with a bug in a completely different code base. So it's like sort of endemic to the use of real-time video and whenever you have low motion.
Pretty generic problem.
Yeah.
Sounds like Caffeine ended up going with Pion. What were the reasons behind, like, let's say, the choice of Pion or WebRTC's implementation, WebRTC.org's implementation? What sort of inputs did you look at to make that decision?
Right. So the WebRTC.org code base, it's very popular. It's a very complete, reference implementation. Basically, it's what was developed in conjunction with the standards. But it's also a very, very large code base, and compiling it takes a lot of resources. It has a very large build system. It takes a very long time to build. And one of the big things that drove us to look at alternatives is that the API on top of it is pretty unstable. So every time you update to a new version, you end up having to do an awful lot of work in the code that actually makes use of it. At the same time, because we were writing the ingest gateway in Go, because we have a lot of folks who understand Go inside the company, we ended up looking at Pion because it's a native Go implementation. And although it's significantly less full featured than WebRTC.org, it did pretty much everything that we needed to, and the few things that we wanted to add on top of it were very easy to upstream into the code base. It's very easy to read, understand, and they're very welcoming of new contributions.
Yeah, the availability in Go was probably a big factor in that decision making, sounds like. Awesome. Yep.
And I made the same decision. As a Pion contributor who tried to use WebRTC, it's a pain. Use Pion.
Great. It's good to hear common inputs towards similar decisions. Maybe move over to Thomas and Jordi. When you look at reliability at any point and take dual paths or redundancy, there's always a question about cost and implications on other metrics like latency. Was that a factor you guys were looking at when thinking about this dual path and maybe potentially multiple paths down the road as well?
Yeah, it's certainly something that we thought about. But the way I like to think about this is like we've exposed a knob that we can now use to control the level of reliability that we can allow ourselves like over this hop. So in the more extreme cases, for the cases where, we think we might have a problem with reliability, or for particular classes of streams where we care more about reliability, we can do, more extreme things like always writing over 2 paths or even 3 paths to get the maximum level of reliability. But for classes of streams, perhaps where we, care less about reliability, or we think that the link is more reliable, we can fall back to less pessimistic types of strategies, such as, writing over the first link, and if that fails, like after a particular relatively short timeout, then we would write over the second link. And then over the, on the other side, the reader would, read that from both links in a very similar way. And so we can actually get, from our experiments, pretty close to the same level of reliability by doing this kind of, only write over the second link when we really think we need to, with lower cost from both a storage and a network link perspective, but maintaining almost the same level of reliability. But we can always roll out the red carpet for like the super important streams where we're like, willing to spend a little bit more to get a higher level of reliability. And from a double storage perspective, we, aren't necessarily paying that cost of like storing that entire stream from start to finish, like in this storage. And we're only, kind of storing the, the transient data that needs to be stored for like a relatively short level of a short amount of time. So the storage is, it costs money, but it's not like we're like storing every single stream for all time in expensive VRAM. So yeah.
Okay.
Just for latency, also that I think you asked about latency, we added another knob on top of all what Thomas explained. That is the size of the frame that we're writing from the edge to data center. So if the streams is, let's say, normal latency, so that we could spend 300 milliseconds more, then we can write we can move that knob and write from edge to data center every 10 frames, for instance, 10 video frames. That could add more or less, let's say, 300 milliseconds of latency. But the cost, the CPU cost in our system, it will be lower because the IOPS are lower. For streams that are ultra low latency, that we care a lot about latency, we can just switch them up and write every one frame, every one video frame. And that will add just 30 milliseconds of latency, but there will be a cost to pay in IOPS or in CPU.
Yeah, that's fair. Now, the other consideration, anytime you take dual paths, dual redundant paths, is how do you synchronize between the two paths? Like for a viewer that goes from one path to the other, do they see any jump or skips, or did you factor in any synchronization between the dual paths so that it's seamless for the viewers?
No, so it's let me start from the end. It's absolutely seamless for the viewers. So the viewers will never see even a glitch. So the way that we manage that is that, for instance, in healthy conditions, so both paths or end path are always more or less in sync. So perhaps a few milliseconds out of sync because one path could be longer than the other, but are more or less in sync. In a problematic case, let's say that one of the paths is congested or is down, then the reader will read from the healthy one, and when the other path recovers, it will automatically catch up. So basically, a way to summarize it is that all of read and write operations are done at byte level. So basically, it means that the reader is always able to reconstruct perfectly at byte level the stream that was ingested in the POP. So basically, that's why I started by saying that the viewer will never see a glitch as long as one of the both paths is up at any given time.
That's impressive. Thanks for explaining that. One question is coming up live from John. Is Rush along with RTMPS is how we stream to Meta today? Is this something supported by third-party streaming services?
So we don't have a lot of support for Rush in terms of third parties today, and like the primary way that people are publishing live streams into Facebook or Instagram today is via RTMPS. We are looking to change that though. And so some people might be aware that we've been talking about Rush. We've published an IETF draft for this. And also at the same time, we've been working with folks like Luke on the MOQ mock IETF working group to kind of build something that we hope will replace RTMPS for ingest. And also we've been talking about how such a thing might work with egress as well. So I'm hoping that these efforts will help us to replace RTMPS with something that is better, works over quick, and sort of integrates all of these interesting things like we've heard Luke talk about with Warp.
Yeah, we need a standard. Otherwise, third-party like open source software is just not going to implement something for just one website. So we're working on it.
Yep. Maybe going back to Adam for another live question. Have you considered contributing a bug fixes back to FFmpeg?
Oh, definitely. Yeah. So the problem is fixing this is a breaking change on the wire. And so I can't figure out how to do it in a way that's not going to cause problems for people. Casting it in very selfish terms, if I were to submit a patch that fixed this problem and then upgraded to the resulting FFmpeg, our network would break. So it's like, and we're not the only ones that are going to be in that boat. There were other people who are going to have that same problem. So if I can figure out a way to navigate those waters, I would love to get a fix in. And if anyone has ideas, like clever ways we might be able to finesse that, I'd love to hear about them. But for now, I think it's kind of a non-starter.
Thank you. Looks like we're doing pretty well with time, so we can take some more questions that came up earlier for Luke's talk. Are there any benefits for adaptive bitrate streaming to call out when looking at QUIC? Does QUIC provide any benefits for ABR versus when you compare it to other protocols?
Yeah, so I briefly mentioned it before. One of the benefits of being in application space is you can actually get the information very easily. Like, you can literally just say, hey, quick library, what's BBR estimate the bitrate to be? You can do that with TCP. It's just like kernel syscalls. And there's also quick ACKs are better. They contain some timing information. So it's not quite transport-wide CC in WebRTC land, but you can make better congestion control than TCP using quick. We want to kind of bridge the gap because there's certainly some things that WebRTC does really well for real time. And there's things that quick could do better. And part of, again, this working group is to figure out how to bridge that so we can handle the full spectrum of latency.
Awesome. Another question for you, Luke, on codecs. Like when we look at media over quick, are we taking into account the behaviors of encoders? And so, for example, if scalable layer-based compressions like SVC or LCEVC are being taken into account, or is it pretty codec agnostic?
Yeah, so the fundamental goal is to try and map the way media is encoded to the network and do it with like quick building blocks instead of fragmenting everything yourself. The nice thing with SVC is it's pretty easy because it's just effectively a quick stream for each SVC layer. So the common ground between warp and rush that we've kind of settled on and we're pushing as the media over quick standard is to any number of frames as a stream, which is effectively to say an SVC layer is a quick stream. And it still does the same prioritization delivery order. It'll work great with SVC. I haven't tried it. I haven't messed around with SVC, but this seems like the very natural way of actually sending SVC over to the internet. Far more natural than something like RTP.
Great. This is, I was curious about this one as I was hearing through your presentation, Luke. I would guess that interactivity is very important for IBS, and data channel kind of is the way you kind of transport or deliver a lot of the interactive data. How is time metadata or data channel dealt with in the lossy scenarios? Is there would they get dropped if the buffer goes beyond a certain limit, or there is separate affordance for data channel so that it's more reliable?
Yeah, so I've done my time with data channels. You kind of have to if you want unreliable in the browser. But now there's web transport. Effectively, it's in Chrome. You get quick in the browser. And part of Warp is that we just use some of those web transport streams. You can use the rest for whatever you want. In fact, web transport also has datagrams. So the plan right now, I haven't really done too much thinking about time metadata, but just to send them just like a video or audio stream where they have a priority to say that, they are the most important or they're the least important. It's up to you. But if you really want, you can send arbitrary application data over quick. You can share the connection with the media, make as many streams as you want, or send them over datagrams if you really want. Yeah, application data is definitely supported. But we'll also natively support timed metadata, I hope. That's
impressive. That's great. I think we can take one last question on the chat as a follow-up. And this one is for Thomas and Jordi, for you. What do you think about reliability when considering third-party streaming services using Rush? Or is that something you're concerned about?
You want to take this one, Jordi?
Yes, but what do you mean? So about concern about third-party implementations of Rush?
Yeah, is reliability even important when you're looking at third-party encoders like Elemental, Wowza, or others? Or is that part of the consideration?
Yeah, so reliability is always super important in live streaming. So apart from for me and also for Meta, And yeah, we have that very into account. So right now with Rush, it works over quick streams. So basically, it's a reliable protocol. But as Luke mentioned, so we are in that media over quick group, and we are planning to move towards not fully reliable. I don't want to say unreliable, but not fully reliable protocol. So, and then when we move to that, we need to figure out a lot of things. But I think Luke described it perfectly. So add prioritization. So make sure what we want to lose, what we cannot lose, and make the most of it. I don't know if that's the question. I
think the question probably implies like, are there affordances in the protocol to allow reliability to be tweaked versus latency? Because you're always making trade-off between latency and reliability. Does the protocol provide enough hooks for one to control how reliable they want it to be compared to latency? What sort of trade-offs are there other hooks to control that trade-off?
Yeah, I think that the media over quick group it's just I think it was just created a few weeks ago, so it's very new. But definitely the proposals that are on the table, they have that lever, that knob available. So with exactly what Luke was mentioning of prioritization, we can just tweak reliability versus latency. So we put if you can receive all the data and you have enough buffer and you have a big buffer and you can receive all the data, perfect. A little bit more latency, but you reduce the buffer, you receive less data, you lost the data that has lowest priority, and that is the knob, that is the reliability latency knob, in my opinion.
Yeah. Effectively, at least the broadcaster always sends media the same way. So third parties can just import a quick library and just push it, and it's very simple. And then it's up to the viewer to decide that latency versus quality trade-off. It's effectively that buffer size is how long am I willing to wait for a frame? Mm-hmm. And you can set it to 10 seconds if you have a poor network connection. You can set it to half a second if you want, real time. And it's just the viewer chooses that trade-off, which is kind of cool, not the broadcaster.
Yeah, and when Luke says viewer, I think he's thinking on the agri side. I'm always thinking on the inches. Yes, exactly, the consumer. Yeah, so it works both ways. So yeah.
That's great. I think that was our last question. So we can take a 30-minute break. It's almost 30 minutes. Our next session, which will be the third session of the day, is coming up at 12:15. So 31 minutes from now. This is like Pacific time, 12:15, 4:15. Eastern time. So see you all back soon, right here at Facebook Live, with 4 more amazing talks coming up in the third session and another 4 in the fourth session. So see you all back soon.